So this is our triple output power supply lab. Let's see how this goes. So we're going to need a 1 kilo ohm resistor for load and a 4.7 microfarad capacitor. Let's go find those. All right. So you have our resistor and our capacitor. Let's measure the resistance. .85 kilo ohms. Now the capacitance. .64 microfarad. All right, so we need to measure the peak-to-peak voltage on the secondary side of our transformer. So this isn't the same transformer that we use in class, but it'll do for this experiment. Now to measure peak to peak, I'm going to have to use my oscilloscope. And you guys are a little spoiled in class. This is the oscilloscope that I'm used to using. Let's let it warm up. Everything on this oscilloscope is essentially the same as what you use in class. However, this is actually what the wave looks like, not a digitally made one as we have in class. So I'm going to plug in our transformer to mains. Alright, that's pretty much what we want. Let's see what we're set to. 10 volts, so let's just try to eyeball it for a little bit. So we have 10 volts, so 10, say it's 12, 13 volts. That's for positive, and then the same for negative. Okay, today we're going to do some measurements of this circuit. Some are in the lab, some are just for fun. So let's see. Let's start by finding some frequency. that's putting off, and the amplitude. All right, let's see now. It's fairly good. Let's see what this the peak amplitude is. Let's try to center it a little bit. Okay. So according to my old oscilloscope here, it is, let me get a pen. It's roughly 15 volts amplitude, not amplitude, but at the first peak, roughly negative 15 volts. As it warms up, everything shifts a little bit. So we're getting about plus and minus 15 volts here. Okay, and let's see what it looks like after rectification. Okay, that doesn't look quite right. Let's see after smoothing. Well, that looks a lot better. Oh. Being in DC, that's going to make a huge difference. There we go. Zero this out. All right. So after rectifying, we are getting set 10 volts. Let's set it to the same voltage. So we're getting roughly the same thing peak to peak. It's a little lower, and the way you can tell using this oscilloscope are the traces are slightly higher than these traces here. So we are getting a full rectification because we don't have half the peaks. We have all the peaks. They're just all in the positive region. Now this is after smoothing. You can see if I zoom in, well, first let's measure the voltage it is after smoothing and after peak. So we have roughly 16, 17 volts. Or is that correct? Roughly 18 volts. All right, so now let's try to see the timing of the ripple, so how long it takes to discharge this nice long line here. Let's zoom it in to make it a little easier. There we go. The voltage ripple is what really tipped me off there. That's more like it. So now we're getting roughly 2 volts for the ripple voltage. So the discharge time of this with this capacitor is roughly 6 milliseconds. Okay, so let's say the average voltage output is going to be, we're going to have to zero this thing out again. Average voltage is probably going to be just below the peak, so around 15 volts. Okay, just for fun, let's find the AC voltage across one of these leads. About 10.8 volts AC. Let's check DC. .8 volts. And the current going through . Well, that's between 1 and 2 milliamps. Alright, so let's change out this capacitor and do it all again. Okay, so now we're going to need a zoom in again. Okay, so we're roughly getting 1 volt peak to peak on the ripple voltage. Now let's work on the discharge cycle. So that's roughly let's say 7 milliseconds. Which doesn't quite make sense. See if I can get another wave on here. Maybe I'll have more luck. Man, these waves are all over. I guess we'll keep it. Average voltage. About 14 volts. Let's find the current. Same, about 1.